Hello. Hey. Good afternoon, Øredev. How are you doing? Last day? Everyone having a great time? I know I am. And I'm here to talk to you. Well, let me introduce myself first. My name is Huyen Tue Dao. I'm an Android developer working on the Trello app for Atlassian. And I want to talk to you about one of my favoriteest new subjects in Android, and that's the constraint layout. How many people here have used constraint layout before? Okay, that's a good amount. So what I want to talk to you today about is two things. I want to talk to you about the cool things about constraint layout, and I want to talk to you about the cool things you can do with constraint layout. So it seems like a fair amount of you know what constraint layout is, but I'm still going to go through just a quick intro. So basic constraint layout is a new layout, a new platform layout that allows you to build UIs through relationships between views. So it might sound like, and kind of is a kind of new, bigger, badder version of relative layout. And there's a little bit of linear layout that lives in it as well. And what the really interesting thing about constraint layout is its expressiveness. It's not just kind of a better relative layout, but it actually is more expressive. It kind of gives us more tools to build relationships in better and new ways that we didn't have before. And through that expressiveness, it actually allows us to be more performant. So if you came to my talk yesterday about custom views and view groups, you might have heard me kind of talk about performance in a little bit, and about how performance is tied to the complexity of a view, the depth of the hierarchy, and literally how many views you have on the screen. So constraint layout actually helps us in performance in that it allows us, because of its expressiveness, to build more complex UI with a single layout. Less nesting, less putting linear layouts inside of linear layouts, and again, reducing that view hierarchy. And so allowing us not just to do more interesting things, but to do them more efficiently. So a couple more things about constraint layout. Number one, it's unbundled, which actually has two benefits. So number one, it allows the very hardworking team that is working on constraint layout to iterate very quickly, to add in new features, to fix bugs. And not only that, by being unbundled, for you as kind of a consumer of this library, if you find a version of constraint layout that works for you, you can stick with that as long as you want. If something changes, if something new comes in, it doesn't quite work for you, it renders a little bit differently, you don't have to worry about that. You can move on in your own time. If you happen to be supporting all the way down to API 9, number one, my condolences, but number two, you can actually continue to use constraint layout all the way down to API 9. Now, there's a really great UI builder with constraint layout, and I say that as someone who has been very, very critical of WYSIWYGs in the past. I absolutely abhor WYSIWYGs, just a lot of trauma and bad experiences. But I'm actually very positive and very kind of, I like the UI builder with constraint layout a lot, and it's actually built in conjunction with constraint layout. It is meant to be used with constraint layout. You can kind of see that in the functionality and the kind of extra power that it provides you. Because of these more complex and more expressive layouts, the UI builder gives you visualization. It gives you a very easy way to glean and grok what's going on in the layout just visually, rather than having to read everything in XML. But that is not to discriminate against those of us who love XML and refuse to do WYSIWYGs. You can do everything you can in constraint layout in XML. And in fact, there's actually some features in constraint layout that haven't quite gotten a kind of UI tooling for. So if you're an XML person, you're totally square. The latest release of constraint layout is 1.1.0 beta 3, which was released not more than a couple weeks ago, I think. So really quickly, how does constraint layout work? Constraint layout is based kind of on a three-part system. And the part that we work in as developers is the constraint system, the kind of constraint level. These are how we define our relationships, how you position items, how you size them. And so there are position constraints, dimension constraints. And there's a lot, well, now with 1.1, there's a lot of extra kind of virtual helpers is what they're called, and other classes that kind of provide us extra ways to build these relationships. And we'll talk about just some of them today. So basically, as a developer, you build relationships, you build these constraints, and the constraint layout takes those relationships, and those relationships have unknowns, right? Because we're doing things relatively, we don't know as we're building it the exact final size and position of our views. That's constraint layout's job. And the way it does that job is to take these relationships that we build and turn them into a linear system of equations or inequalities, and it takes that linear system of equations and inequalities and solves for those unknowns using the okay, I'm going to have to read this one. The cassowary linear arithmetic constraint, solving system. And this is actually the kind of system, it was written by two gentlemen at the University of Washington, I believe. And it's actually the solver used in iOS's auto layout. So any of you kind of iOS fans out there, hey, we share something in common. And what it does is basically constraint layout will pass this system of equations into the solver, and out comes the final size and position of your views. Now, if this kind of stuff is fascinating to you, which I find it fascinating, Dave Smith, who is now the developer advocate for Android things at Google, but previously just wrote a ton of wonderful deep dives, technical deep dives into things on the Android framework. He wrote a really great blog post kind of about kind of this level and the solver and everything like that. So definitely check it out if this is something that's kind of fascinating to you. So a really quick tour of constraint layout within Android Studio. And so here it is. You kind of get a specialized UI when you have a constraint layout in the Design View Builder. And so on the left, we have kind of the typical palette where you can pull out all of the wonderful platform widgets. There's the component tree where you actually can see the list of views inside of your constraint layout. And when we focus, so this is blueprint view, which shows you kind of a structural view of your layout, but you also have design view, which is kind of like a preview of the rendering, and you can also do a side-by-side design and blueprint. Now on the right, you have the attributes panel, and you have this new kind of constraint widget that is a visualization of the constraints on your currently focused view. And then if you want everything, you can get everything by clicking all attributes. Now, when you have constraint layout kind of focused, you get a very specialized bar, which has constraint layout specific tools. So there's things that you might want to read up on later, like interference, auto connection. There's actually some really interesting IDE tools like alignment and packing, just things that are meant to make UI building a lot faster. And you can actually access some of them through the context menu when you right-click on items in the component tree. So don't hesitate to try the UI builder. They've really been trying to iterate on it and make it a much more usable and kind of helpful experience. Let's see. Now, just to kind of go over a few things for those of you who haven't quite used constraint layout a bit, we're going to talk about some terminology. So the very simplest kind of constraint, relationship in constraint layout, is the edge constraint. So the edge constraint is basically positioning one side of a view relative to another. And edge constraints always consist of a source and a target. So the source is the view that you're constraining and the side of that view that you want to constrain. And the target is the view and the side of that view to which you constrain. And in Android Studio, you'll see whenever you see a view like this, you'll see kind of 4 little bubbles on each side. Those are called anchors. And if you are a WYSIWYG type person, you basically click on one of those anchors and drag to the target that you want to constrain that anchor to. And if you're an XML person, you might write something like this. And kind of like the general format of the attribute is layout constraint, the name of the source side of your view, and then to the target side, the side of that target that you want to constrain it to, and then finally the view ID of your target. Now, if you have an edge constraint on one side of your view, and you match that and you create the corresponding constraint on the other side, you now have a center constraint. So rather than positioning a single side of that view, you're actually positioning the center of the view. And what's really neat is that when you have a center constraint, very often you have space at the start and end of that center constraint. And what happens is in constraint layout, you can actually control the distribution of that space using the bias. Now in the UI builder, you'll see when you have a center constraint, this little slider. And as you move that slider kind of back and forth, you can see that that distribution of space at the start starts to move with that slider, with that bias. So you can do some really, really neat things with that. Keep going. Now, you can actually set the bias in XML using this constraint, either horizontal or vertical bias. And the value that you give it is some value between 0 and 1, representing that the percentage of space that you want at the start of the center constraint. Now, a lot of times when we're building UIs, we're working with text. And as many designers have had to remind me, when you have several pieces of text, generally it's good design to align them by the baseline, by that line that text tends to sit on. And you can do that very easily with constraint layout using baseline constraints. Now, to do a baseline constraint in the UI, you might see, it's a little bit hard to see exactly, but there are 2 kind of blue buttons below kind of this view on the right. And there's one that has like 2 letters and what looks like a baseline. So what you do if you want to do baseline constraints in the UI builder is you click on that button and it reveals a anchor constraint. And what you can do is drag from that baseline anchor to the baseline anchor of another view, and you can just automatically align two pieces of text on the baseline. So pretty simple. And if you wanted to do it in XML, this is what it looks like. So in lieu of doing, say, a start to end constraint type thing, you'll do something like this, constraint baseline to baseline, passing in the target ID. And so something very, very, very new in 1.1 is circular constraints. So this is pretty interesting. It allows you to position views relative to another view. You basically position the center of one view relative to the center of another view and giving it an angle and a radius. There's not a UI tooling that I've seen for this yet, but you can do it in XML. So there's three attributes that you have to specify. The first one being the target of this constraint. The second being the angle at the angle at which you want to position your source view, and then finally the radius at which that needs to be positioned from the center of the target. So in terms of dimension constraints or size constraints, there's kind of three main categories. The first one is fixed, which is kind of what we're used to when we're doing just regular old Android UI development, basically a hard-coded size and DPs, hopefully, or a dimension resource. There's also wrap content. So again, kind of having its size wrap the kind of intrinsic content size of that view. And then there's also match constraint. So in constraint layout, we don't have match parent, and you'll actually probably get either lint errors or lint warnings or errors when you specify them. But basically, match constraint is kind of a value of 0 dp. But what it allows you to do with a view is to actually allow it to take up as much space as possible for between the kind of extremes of the constraints on that view. So it kind of resembles, actually, like if you think of fill parent, because way back in the day, Android's match parent was fill parent, and people kind of got that confused about what that meant. You can actually think of match constraint more of like what fill parent was, what people thought fill parent was. But yeah, and then if you look in the kind of widget, the constraint widget in the attributes panel, there's actually usually a pair of orthogonal lines that will represent kind of what kind of size constraint you have along those dimensions. So with match constraint, there's actually some interesting things going on. There's kind of a lot of modifiers. So that's something that kind of has happened a lot in the last year of iterating, that people have come up with edge cases that the lovely constraint layout team have tried to address through adding modifiers to match constraint. So you can actually set a kind of max or min width or height so that you can kind of control the expansion of that view, even if it has match constraint. And you can specify either an actual kind of dimension or dimension resource, but you can also set it to wrap, so that you can either set the minimum or maximum to be wrap content. You can also do percentages, because that comes up all the time. And you can actually have the width or height be a percentage of that parent constraint layout's width or height. And finally, my favorite is dimension ratio, where you can actually set the relationship between the width and height of a view as a ratio. And I'll talk about that a little bit more in a second. So one of the virtual helpers in constraint layout are guidelines. Now you can think of guidelines as basically an in-UI version of material design keylines, and they're basically these vertical or horizontal lines that you can use as targets for edge constraints. So as you can see here, I have three guidelines actually, on the left, the right, and one on the bottom, and you can form edge constraints using those guidelines. And what's really cool is that if you move a guideline, any views that are targeting that guideline will move with it. So you can see it's a very handy way of keeping things aligned along these material design keylines without having to manually go in and fix the margins or positioning of each one. And there's basically a few different ways of defining guidelines. One is defining a guideline as some offset from the start of the constraint layout, defining a guideline as some offset from the end of the constraint layout, and then as some percentage across that dimension of the constraint layout. Now, if you're an XML person, this is what it looks like when you want to create a guideline. Now, under the hood, guidelines are technically views, but they are not included in the rendering at all, so you don't have to worry about them kind of performance-wise. But this is how you specify them. And again, because there's three different types, begin, end, and percent, that kind of changes the format of the attribute. But as you can see on the bottom of those two tags, that's basically how you do it. So something also in 1.1 relatively new are barriers. Now, barriers are kind of an interesting spin on guidelines in that rather than having the guideline having a specific kind of position-based rather than specifying the position of the guideline specifically as left or right offsets, the position revolves around views. So if you take a group of views and specify a barrier for that group of views, the barrier positions itself to be aligned with the view that is positioned furthest along that side. So let me actually show you an example. So I have two text views. These text views are within my barrier, and my barrier is that kind of line, that kind of dotted guideline in the middle there. Now my barrier here is set to direction end. So that means that barrier is going to be looking at the end edges of those views that are kind of grouped for that barrier. And what's interesting is that as the content of those views change, as the widths of those views change, the barrier will continue to check which view here is farthest, which view has the farthest end edge and aligned to that content. So as you can see, as that top text view is getting shorter and longer, the image view, which is aligned to that barrier, will move in position with it. Pretty interesting. And I think it kind of came up from one of those edge cases that people have. And so the lovely constraint layout fellows have added it in for us. Now, again, because it's a guideline, similarly, it's also technically a view under the hood, and you can kind of declare it in XML in this way. And the important parts are specifying the barrier direction. Now, again, that's the side of the views that the barrier will align to. And then the reference IDs, which is a comma separated list of the view IDs that the barrier will try to align itself to. Another interesting thing in 1.1 are groups. So groups are kind of like virtual groupings of views that don't affect the layout. Now, right now, groups don't do too much, but they do allow you to toggle the visibility of that group of views. And you can do them very easily. You can create groups very easily within the UI. So you can do something like selecting, say, 4 out of these 5 buttons. You can go in, create the group helper, and you can actually drag views into that group. So these views are now associated with that group. And if you click on that group and go over to the visibility toggle within the attributes panel, as you toggle the visibility, both in UI and also programmatically, you can see how the visibility of those views as a group will change. So that's kind of a great way to do that. Hopefully, I think in the future there's plans to expand the functionality of groups, but that's basically what they are for at the moment. So what are the really cool things that we can do with constraint layout? So I want to ask, has anyone ever had to do something like this, where you want a square view of some sort, and you have to end up like extending image view and very explicitly overriding on measure, finding out which is the bigger view and setting it to both the width and the height. I've had to do this more times than I want to count, and it's really painful and annoying where something so simple, a square view, takes so much code. Well, in constraint layout, you don't have to do that anymore. So one of my favorite features, constraint dimension ratio, is allowing us rather than having to so explicitly go in and extend classes to, again, allow us to change size the width and the height as ratios of each other. So in this case, I have an image view, and both the width and the height are match constraint, 0 dp. And then I have this constraint dimension ratio attribute, and I'm setting it to be 1-to-1. So basically what that means is that as, say, the height changes, the width will be changed by the constraint layout to maintain that 1-to-1 ratio. Now you might notice that I have a kind of W here as a prefix to my attribute. Now normally you don't have to have both of them be match constraint, but say I have both of them, so that means that they're both going to kind of like fill up the available space. By specifying this prefix, I can say, I'm basically telling constraint layout, hey, can you let the height be whatever it wants to be based on the constraints, and then have the width adjust to maintain that aspect ratio, and that's what that means. So just a kind of a quick example of what you can do with it. I think image view is a really compelling use case for dimension ratio, just because images have that kind of intrinsic aspect ratio. And there's so many times I know, like when I'm doing like photo apps and things like that, where I'm doing all this math to kind of calculate aspect ratios and multiply width by height. You don't have to do that any longer. You can just very simply give this attribute a string and say in very plain natural language, hey, this is a 16:9 image. Very powerful and honestly really cool. And what's neat is that you can actually still use resources. If you're kind of a big nut about dimension resources like me, you can actually specify aspect ratios for the dimension ratio in your resources. You do have to make them a string because they're not exactly dimensions. But as you can see here, if I define a string and put in, say, like, again, constraining the height to be 16 by 10, I can just go ahead and stick that right into the attribute, and it works just fine. So so all this is great. All this fancy stuff is great. But really, I mean, what incentive do we have to use constraint layout over something like relative layout? So as I mentioned before, performance is kind of one of the main selling points of constraint layout on top of all this expressiveness and all these kind of cool tools. And if you've never kind of heard this before, relative layout does in fact allow you to also build relationships between views. But the way that it gives you that power, the way that it resolves those relationships is by taking two measure and layout passes in the kind of process of drawing that view. And while that doesn't seem terrible if you just have one relative layout, a lot of times when we're building UIs, we find ourselves nesting them. And as you can see, the performance impacts become exponential. And so what constraint layout allows you to do is to actually circumvent that by flattening things. So rather than having a lot of different views that are nested, you can have the constraint layout use expressiveness and kind of implement a complex layout using just constraint layout. And so that makes your view hierarchy less deep, uses less views, and makes your performance better. There are some other things too, just some little quirks about how constraints are defined that kind of bring you a lot more power. So in this layout here, I have an image view. And I have, well, you can't see it because it's in blueprint view, but the little square on the right-hand side is a floating action button. Now, according to material design guidelines, if you have a hero image, so that those big images that you see often in material design line that kind of float at the top, and if you have a fab on top of that, the center, the vertical center of that fab has to be aligned with the bottom edge of that hero view. Now, if you have like coordinator layout or something like that, you actually get that behavior for free. But if you're not using coordinator layout and you want to do this, it actually takes a lot of work, right? Because you have to measure the fab and then figure out what half of that like height is and then do some kind of offset or margins or something just to get it aligned. And woe be you, if that image view changes size, you'll have to do those calculations again. But it is super, super simple to do this and describe this behavior in constraint layout. So it's a little bit hard to see, but that fab that I have in my constraint layout, I'm constraining the top of that fab to the bottom of the image view, and I'm constraining the bottom of that fab also to the bottom of the image view. Now what this does, it actually creates a center constraint, a vertical center constraint on my fab, and what happens is that now that center will continue to be aligned with the bottom of that image view, even if it changes size. So here I have a quick example. I have some toggles that will change the aspect ratio of that top image, which means that the height changes. And as you can see, the fab just very kind of faithfully follows the edge of that image. And I didn't have to do anything other than create the center constraint. I did it. It all comes for free if you define the correct relationship between views. And I think that's just so, so powerful and so interesting about constraint layout. Here's another example. Oh, by the way, this little trick I got from Mark Allison's blog, Styling Android. He did a really great, I think, 8-part series on constraint layout. And this is just one of those tricks that I picked up from there. And if you're really interested, Mark Allison does amazing blog posts about kind of UI-centric aspects of Android development. You should definitely check it out. So here I have something that I've done at a previous job. So I actually, on a previous job, I was doing this kind of photo editor thing where I was like, I could kind of gave like a photo like handle so that I could like pinch and zoom and crop so this photo could be sent off to printers. And doing handles like this is actually a big pain in the butt without constraint layout because again, when you position things kind of along edges like this, you have to do a lot of math, calculating the height of things and then adding offsets and then, oh my gosh, there's padding in the view as well, so I have to add that in as well. But again, with constraint layout, because I can specify these center constraints, I can do this so much easier. So my example at the top, each of those like little pink handles are positioned using center constraints. And all this slider, this crazy slider that apparently I was just like really excited and just moving around a lot, all it's doing is changing the size of that handle. But because I have these center constraints, that's all I need, that center constraint, and constraint layout will keep those handles centered for me. Now the bottom is done using kind of like the old-fashioned way that I did at my old job, and the code for that looks like this, where I'm pulling out layout margins and I'm doing math and it's just a lot of code. And again, it's programmatic, whereas doing it through constraint layout, I do it in a very declarative XML-based way or UI way if you're a WYSIWYG type person. So again, constraint layout does not just give us these kind of fun, cute tools, but it helps us be more efficient as developers and help us to do things in a more declarative, less imperative way. So I mentioned that there's a little bit of linear layout living inside of constraint layout. And that linear layout behavior is encapsulated in what are known as chains. So chains are basically linear, so groups of views within a constraint layout that have linear relationships. And a chain is defined as a group of views that have bidirectional relationships. So what that means is that, say in that top chain where I have A, B, C, so A is connected to the parent, but also connected to B. B is connected to A and also to C, and C is connected to B and also to kind of like the endpoint, say the parent again. So again, bidirectional, everything's kind of connected to everything else. And what the chains allow you to do is allow you to position not just views, but also the space around that view. And chains have something called a style, which kind of dictate this behavior. Now, the default style of a chain, when you define a chain and define those bidirectional relationships, is the spread chain. So if you look at the very top chain here, all of the space that's available kind of between the endpoints of that chain is distributed evenly between A, B, and C and kind of on those outer edges. There's also a style called a spread inside chain, which basically means that rather than the space is not distributed kind of at the extremes of the chain. And there's also a thing called a weighted chain. Now, a weighted chain will feel a lot like a linear layout with weights, where you can actually set weights. Now, if you set a weight on one or more elements within a chain, the weights will actually basically signal to the chain that, hey, rather than having the space be external to the views will actually now take in that space. And the weights will determine the proportion of space that each view gets. And the final style of chain is actually my favorite. It's called a packed chain. So what a packed chain does is it takes all of the views in a chain, smushes them together, and then distributes all of the space to the start and end. And what's really neat is that now you can actually apply a bias, just like this was a center constraint, and you can apply a bias to distribute that space between the start and the front. So it basically turns a whole bunch of views into one big view. And so in XML, this is what it looks like when you want to change the style. So when you're applying attributes to a chain, you always have to look for the head of the chain. It's basically like the chain's captain. Now, for vertical chains, the captain, the chain head is the topmost element. And for horizontal chains, the head is the leftmost. And when you define a style, you'll use this attribute, constraint vertical or horizontal, and then chain style. And you can specify, whatever chain style that you want. Here, for the second chain, I've got spread inside. If I wanted to do a weighted chain, again, at least one of the constituent views has to have match constraint, so that's 0 dp. And now I can see each one of these actually has a weight so that I can distribute that space. And that's what I get in that third chain where I'm distributing that space, and so that the B view kind of greedy, is taking up most of the space in the chain. And finally, the packed chain. And what's interesting about the packed chain, again, is that it's essentially creating a really big center constraint out of all the views inside of it. And you can set a bias. Again, like any settings you do have to be on the head of the chain. So once you find the head of the chain, you set that bias. And as you can see here, I'm actually changing the bias with this slider. And as you can see, it kind of just shoves that whole group of views back and forth. Really, really neat stuff. Okay. Here's me going crazy with chains. And I think this is really, really fascinating about chains is that, again, it kind of shows you how much more concise and flat you can be with constraint layout because you have this very powerful and expressive way of building these relationships. Now, I actually have 5 chains here. I have 4 horizontal chains and 1 vertical chain kind of going up through the middle. Now, if you wanted to do this without constraint layout, you can really easily imagine like 5 linear layouts nested inside one like bigger like view or container rather. And what's really interesting here is that with a linear layout, the position of views in the linear layout, is determined by whether they're adjacent to each other in XML, right? So basically, if something is next to each other in the linear layout, it'll be next to each other kind of, in XML rather, it'll be actually rendered next to each other, right? But as you can see here in this example, that vertical chain, so that thing that's sneaking up through my text views there, those views aren't adjacent to each other in the XML, but they still have that like relationship to each other and can be positioned. And just to show you what you can do, I actually hooked up 2 buttons at the bottom of this application, and the left one will actually toggle the style of the vertical chain. So as you can see, the views in these horizontal chains are kind of maintaining their position to each other, but now vertically I'm switching between spread, inside, and chain impact and all that. And then the right button actually toggles the style of that horizontal chain. So you can kind of really see what kind of complex behavior you can get from these chains. Because you are so directly creating these relationships, you can really build on that and do some interesting and slightly crazy things. So I guess this kind of makes me kind of come to a caveat in that obviously you can go a little bit nuts here and get almost very literally spaghetti going on within the constraint layout. So that's also why that UI builder is really important. When you're looking at this in XML, it can be very difficult to tell where chains start and end, where's the head of my chain, just because of the fact that you can make chains from views that are not adjacent to each other. So that's why the UI builder becomes extremely important. And also, again, just a caveat, like while constraint layout is very powerful and lets us do things, there's still something to be said for making your UIs more modular and kind of knowing when to break things up a little bit. So this is something that's really special and one of my favorite things about constraint layout, which is the constraint set. So basically, a constraint set is a way for you to define a set of constraints, a set of relationships between views programmatically. And it's almost like kind of saving the state of a constraint layout. You can create a certain state, save it, and then bring it back and apply it later. And there's 3 different ways of building a constraint set for a constraint layout. The first is manually, so you basically create a new instance of constraint set and then call a bunch of methods on the constraint set API and build very specifically those edge constraints and those center constraints and those dimension constraints. You can also create a constraint set by cloning a layout file. So a layout resource file that you might normally have in an Android project, you can actually clone it and it will build a constraint set object for you and then basically inflate, I guess, for lack of a better word, those constraints into the constraint set. And finally, you can take an existing constraint layout that you already have kind of floating around, some kind of like reference, and you can clone that as well, and it will basically copy all of those relationships into the constraint set. Now, one of the most compelling cases for constraint set is with transitions. And so, now we're kind of all trying to do material design and building delightful, alive UIs that have wonderful animations, and it becomes ridiculously easy to do this, to switch between different layouts with constraint set. So, I'm actually a big fan of a game called Dota 2. It's basically a kind of team-based game where everybody picks a hero, and they, basically it's kind of a defend the flag kind of game. And I wanted to build an app because I love the game so much, and I wanted to have profiles of each hero that you could choose. But there's so many different aspects to the game. I wanted 2 different layouts as 2 different ways to present the information, right? I wanted maybe one view that presented more kind of like, I guess, personal information on the hero, but then I also wanted a view that maybe highlighted their abilities and their skills and things like that. And I also wanted to be really delightful because I really love this game and I wanted to make a really cool app for it. And I was able to do that really simply with constraint set. And I can get this kind of really lovely transition between 2 layouts super simply. All I had to do was create 2 separate XML files with kind of each alternate view of my character and then use constraint set and throw in the transition manager. And I was able to do this animation with basically less than 10 lines of code. And this is what that looks like. So the first line of code is really easy because it's set content view, which we have to do anyway. And after I set the content view and grab a reference to that constraint layout where everything lives, I actually will clone constraint sets, the constraint from that constraint layout into a set. And then I'll actually clone my alternate layout, which is living in a resource file. And so I have these 2 constraint sets. And all I'm doing when I'm clicking that button that switches between those 2 layouts is just switching between those 2 sets. So I'll actually call the transition manager and call begin delay transition. And what that does is it actually just uses the default transition and waits for the view hierarchy to change and then fires off that transition when it detects the view hierarchy change. And then all I'm doing here is I have a Boolean that basically lets me know whether I'm in my original layout or in my alternate layout. And then depending on what that Boolean value is, I'm going to apply either my first constraint set or my second constraint set. And that's it. 10 lines of code to do kind of all of that lovely transition. So a question that comes up a lot with constraint set is, can it be used as list items? Because there's usually people are worried about performance. And I will tell you that the official answer is yes, they can be used as list items. So each of the items in this list is a constraint layout. And what's more, you can do some really crazy things with constraint set. So in this list, every time I click an item, I'm actually using a constraint set to switch between some alternate view that takes that lovely little icon and expands it. So as you can see, not only can you use it and it still scrolls, you can apply wonderful transitions to it. A caveat here that I learned trying to make this example is that Constraint sets are only capturing the state of the relationships between views, so that layout stuff. I actually thought that, oh, well, maybe I could change the text color because you can see, like, you can't really read the black on the picture, the black text on the pictures. And I tried to kind of change the text color in my alternate layout. It doesn't pick that up. So you have to be really careful when you're using constraint set to remember it's all about the relationships and structure. If you have to change style, then you have to do a little bit of extra work on top of that. So I was so enamored of constraint set that I kind of wanted to push the boundaries and see like what kind of silly things I could do with it. So as I mentioned before, I gave a talk yesterday on custom view groups because I'm actually absolutely mad about them. But what's interesting is that I feel like with constraint layout, there's actually less need for them now. Because constraint layout is expressive and it's more performant, there's actually less need for them. But can we still use them to make some kinds of custom view groups easier? Well, we can. So when you're doing custom view groups, if you kind of remember from my talk yesterday, there was a whole buttload of code, excuse me. And there's a lot of different ways you can do custom view groups, right? You can do very generalized reusable layouts like linear layout and relative layout. And if you've ever looked inside of those files, you know that there's thousands of lines of code and you have no idea what's going on to make linear layout and relative layout work. It's just there's a lot of overhead in making these very generalized reusable layouts. Generally, it's easier for you to do kind of these more performant, very specific composite layouts. But either way, doing layout and doing custom view groups is super low level. You're literally calculating the X and Y of each view. And even a simple layout ends up generating a lot of code. And if you want to do anything advanced, like even trying to recreate linear layout, I'm sorry, like my condolences, it's awful in terms of the amount of code. This is an example that I gave yesterday. This is just a very simple list item with 3 views in it. And this is the code that I have. It's pretty verbose. It's actually not that bad in my opinion, but still, just doing something simple does require you to do a bit of math and a bit of, there's some verbosity there, let's not lie. Now, I wanted to see what I could do to kind of do that reusable, more dynamic, robust kind of view group, but with constraint set. So what I have here is kind of a silly example, but I guess was kind of playing around. I have a view group here, and I have 3 buttons at the top. One is add image and one is add text. So basically, whenever I click one of those buttons, either an image view or a text view is instantiated and stuck into my view group. And every time I insert a view into my view group, I'm flipping a coin. And on, say, the heads of that coin flip, I'm going to add that view as an entire row that spans the entire width of my view group. And on a tails, for example, I might just say, okay, well, instead of making a whole entire new row, I'm going to add it as a member of another row. So I kind of almost get like a list, almost a horizontal list within the row. So if I had to do this manually as a custom view group, I probably would just say never mind and go to bed. But it actually is really easy to do this kind of weird, crazy behavior with constraint set. So what that looks like in code is this. So in the case where I flip that coin in its heads and I want to add that new view as an entire new row, this is what the code looks like. That's it. That's all I need. So I take that view that I've just instantiated, I add it to the constraint layout, and the first thing I do is I constrain the width and the height using constrain width and constrain height on my brand new constraint set. And then basically, depending on whether that row is the very first one in my view group or it's kind of like one in the middle, I'm going to constrain the top of my new view either to the parent, if it's the first row, or just to the preceding row, if it's kind of like one in the middle. And then I constrain the ends of that row to the start and end of the parent, since it's going to take up the entire width of my parent. And I just threw in elevation because you can change elevation constraint set, so I said, why not? And then I just take that constraint set and apply it to my constraint layout, and that will create those relationships that I just defined using the API methods inside of my actual constraint layout. Now, in the case of a tails coin flip, where I'm actually adding that new view as an item within the current row, here's what that code looks like. It's just a little bit longer. So same thing, adding the view to the constraint layout, constraining the width and the height. Same thing, checking if I'm kind of in the middle row or if I'm in the very top to know whether I'm constraining to another view or whether to the parent. And here's the interesting part. So when I'm doing my kind of tail flip where I'm adding that view as an item to the current row, I'm going to create a horizontal chain. And it is really easy to create a horizontal chain using the constraint set API. I basically have an array of integers, and each of those integers is a view ID. I feed that into this method to create horizontal chain. I kind of give it the targets for the ends of the chain, which is basically in this case the parent. And then I pass it in a float array, which is the weight assigned to each view. And since I kind of want everything to be kind of evenly sized, I just pass in an array of ones. I give it a chain style, and that's it. I've now created that entire that entire chain of views without actually having to create each of those bidirectional relationships by myself. Again, frivolous setting of elevation, and then applying that new constraint set to my constraint layout, and that's it. That is how I created this kind of really crazy dynamic view group using, I don't know, what was that, like just maybe like 50 lines of code. And so I just think that really shows the kind of really interesting things you can do with constraint set and how it can help us kind of do these challenging things that were really, really hard and really verbose before in a much, much easier way. So if you're a Kotlin fan like me, if you can tell from my shirt, constraint set's really interesting. I actually played around with doing DSL, domain-specific languages, with constraint set. Constraint set API is really awesome because it's very fully featured, but it can get very verbose. So if you're kind of interested in kind of pushing the bounds with Kotlin and constraint set, I actually did a DSL. It's available from the code that I had in another talk. So just let me know. It's kind of fun. And I think what's interesting about Kotlin is it kind of adds on top of the expressiveness of constraint layout and constraint set and allows you, again, to make things more declarative, which is kind of what I think constraint layout is kind of going for. You know, a much more higher level declarative way of doing very complex relationships. So I think what really got me excited about using constraint layout is listening to this episode of the Android Developers Backstage, which is a podcast, if you haven't heard of it, run by Tor Norby of the Android Tools team and Chet Haas on the Android Frameworks team. And they had a great conversation with Nicolas and John, who work on constraint layout, and also Romain Guy was there for fun. And what I thought was really, really compelling was basically their motivations. Like they explained why they wanted to create constraint layout and what their motivations were. And Nicolas said something really fascinating to me. He said that what they really wanted to do with constraint layout is to create a separation between the view hierarchy and the layout hierarchy. And in my mind, what I think that means is that the view hierarchy is the representation in your app of the flow of the app, of, I guess, the relationship of data, that hierarchy of content in your app. That's the view hierarchy. That's the content. The layout hierarchy is all the crazy, silly things that we have to do to get it to look the way that we want to do. Whether that's like nesting things or adding gravity or adding layouts within layouts, that's the layout hierarchy. And I think when I look at constraint set, you can very easily see how they're kind of visualizing this differentiation, this kind of separation of concerns with content and then actual layout. And as you can see with things like constraint set, the content, the views that you have remain the same, but it becomes a lot easier to manipulate and mutate that layout without having to rearrange the view hierarchy. And I think that's just so fascinating. And I think it's a really interesting way to kind of continue to approach doing UIs in Android. So again, the two lovely gentlemen that are working on constraint layout are John Hofford and Nicolas Roard. What I think is really lovely about them, and I will gush about them every chance I get, is because they are extremely interested and responsive to developer feedback. Basically, like on Twitter, on Reddit, whenever someone is talking about constraint layout, they will be there asking questions, responding to bug reports. A lot of the new features that have come in with 1.1, I strongly feel come from them talking to people and developers coming up with these really weird edge cases like, well, how do I do this? And I've got this really particular UI that I want done. And they've actually answered these requests, answered these kind of weird cases with these new features. And again, they're very responsive and they're working really hard. So if you're interested in constraint layout, if you have a feature suggestion, if you have a bug you want to report, please bother these two men. They will appreciate it. And actually last week they gave a talk at DroidCon San Francisco called Advanced Animations and Constraint Layout. The slides are up, I believe, and I have a link. I will post my slides, and in the back I have like a whole bunch of links related to constraint layout. So I posted the link to their slides there. I believe it's probably recorded, so you can definitely look out for the video. There's actually a kind of community site started by Mark Allison. Name popped up again, ConstraintLayout.com. Basically, Mark wanted a site that is community sourced where people can go and kind of leave basic tutorials, kind of recipes and cookbooks for kind of different patterns that people are finding and developing for how to use constraint layout. So ConstraintLayout.com, you should definitely check it out. I actually have stickers for the site if anyone wants them later. And that's it. I really, really encourage you to, if you haven't already, try constraint layout. I really think that it's probably a view of how we're going to continue to build Android UIs in the future. It's expressive, it's performant, and you can do really, really, really cool things. So thank you very much. I'll have the slides up. Again, lots of references. And yeah, thank you so much for listening.